Again, thank you for our MC for that wonderful introduction. So again, this talk is kind of on the three different levels. We'll start with beginner. I think some of you already know some of the beginner use cases of underscore. Then we'll transition to dunder methods, which is beginner to intermediate. There's some dunder methods that other developers doesn't know that exists, right? And lastly, we'll just touch upon some advanced concept of use case of descriptors, which is also revolves with dunder methods as well, specific dunder methods. So again, so I think the MC already mentioned who I am. So currently, not lead software engineer as well. Python is the career coach, so I've been also coaching some career in the community, and I'm also part of different community here in Philippines. Google, Python, um, AWS, and other community stuff. So if you want to access the slides, you can just type bit.ly PythonAsia 2026. It's kind of like long slide, 41 slides, but I'll just run through on every slide so that you'll be able to get at least some use cases for your next Python project, since there's a lot of use cases of underscore and there's a lot of dunder methods, so we will not be able to discuss that. So again, it is better for you also to search as well after this talk for other dunder methods or use cases of underscore. So let us start. So ideally, this is recorded, but here, as you can see, there is like integer 1 and 2. When we add it together, should be 3, right? But it outputted 12. Then, as you can see, I use, that's the reason why I don't want to, pero the case here is that if you do 1 plus 2 in an interactive Python shell, we can see that we will be able to calculate things, right? And the first use case of underscore is that you can actually access the previous value in the interactive Python shell for other use cases that you want. So if we do underscore plus 5, we will be able to actually access the tree. And if we do it again, so let us say times 5, we will be able to access that. So that's the first one. So for those people that time to time uses terminal, it is actually good tip for you to check. So that's the first one. Again, this is more on kind of demonstration as well, and more on deep dive on how you will be able to check or how you will be able to utilize those information. No? So for this one, the first one, as we see earlier on, we actually use integer, custom class integer, and why when we are doing addition, right? It doesn't do an integer add, but it actually do a string concatenation. So this is actually an early dunder method example, which we actually use the dunder method add to technically override on what's the normal behavior of using plus our addition symbol on our data use case here. So here, it should be still like, if I didn't override the other method add, it will do just regular addition. But here, since I override it, it did a concatenation. So that's one thing. But I will deep dive on the other methods on the later slides. So yeah. For the first 5 minutes, I think, or 2 minutes, I already gave two example for underscores. No? So there's a lot more. Quick ways to use of underscore in your daily development. Mostly, this is focused on using the Python interactive shell. So first, for those people, I think data science usually uses Google Colab Notebook, which actually acts as well as Python interactive shell. So for those people, I already talked about this. For those people, let us go here first. For those people that actually do Python, heavy data or heavy numbers on Python, most likely on Google Colab for some calculations, instead, you can actually use underscore as well. That acts as like comma for those big numbers, so that you will be able to actually read on, like, let us say you're dealing with trillion number. This is kind of like simple use case, but effective for those people that usually reads numbers and do calculations directly on Google Colab and Python Interactive Shell. I think one of the main use case for Python as well, so I've worked on some data science project beforehand, so I do usually use this concept of throwaway variable. So usually in data science, we usually train stuffs, right, and do loop, and we don't usually use the, like, let us say, the index, right? So we just use the underscore as a throwaway variable. But don't be, the throwaway itself doesn't mean that the value itself is like, doesn't exist. We are just assigning it on the underscore. So it is just like a more on preference and semantic preference for other data science, that you just use the underscore to indicate that it is actually a throwaway, and we don't need to use the variable itself. So one good example as well here is that when you see, we did a loop for, wait, just taking so long. So here we are creating a list comprehension wherein we are actually creating a 1 to 6 number. But here we are trying to unpack it to a different variable. So regularly, you need to have at least 6 variables, right? So for us to unpack all of those data. But here we actually use, let me just show it, since, by the way, this actually, if you've been in PyCon Davao 2025, this is also my talk. So kind of repetitive. That's the reason why it's recorded, but I'll show it here. So let us say I create a list comprehension for A in range 1 to 6. So the regular list would be 1, 2, 3, 4, 5, right? So regularly, we want to assign it in every variable. But let us say we just want to get the first and last elements of the index. So we can actually unpack it with also a throwaway variable with asterisk. This indicates that everything in between will be assigned to underscore. So if we now do that, it will not throw any error. But let us say I did this and equals to I, it will give you an error since it is too many values to unpack. So what does it mean is that you're unpacking 5 elements into 3 variables. So now, if we do that again, since we are just curious on the last and first element, we can just unpack it like this. So now we can just get the 1 and the 5, right? But sir, where did the elements in between of these 2 variables go? So it is just we just assigned it to the underscore. So by the way, again, this is just more on the preference. You can still do it on, like, let us say A, D, or any variable. You can still do that. So no problem naman. So that's just a stylistic opinion, and most of the time, syempre, we want to have like global way of using things, right? So that's one thing, throw away. Again, yeah. So technically, I think that's one of the beginner friendly or day-to-day things that we can do with underscore, no? Most likely for those people that do data science. So next, this is the one good one part that if you're using Java, I think you'll be kind of reminding you some concepts. But here, we will be also doing definition of variables, right? Specifically class variables, instance variables, right? Since it's a init. So here we have 3 definition. The regular one, self.foo. The next one is self.bar with underscore, single underscore, and self.underscore bus equals 3. So again, you can access, right? You can clearly access the first 2 variable, since the first variable is just a regular instance variable, so it is easily accessible. So for the second one, it's kind of private variable. So it just adds a certain friction for you to access it, and it also acts like also a convention for programmers to do to say that this is a private variable. But when it comes to XYZ, that underscore bus, it doesn't give you the value, even though we actually um, uh, assign the value to the double underscore bus. So what does it do? It actually do name mangling. So I'll be sharing it later on. I think I have, oh, yeah. Yeah, I have name mangling there. So what it usually do, it is technically in layman's term, it is a like secret, a very hidden variable, but it's technically not protected as well. So it's just like doing a name mangling. So for you to access double underscore variable, you need to actually prefend the class name. So I haven't able to actually show the full code here, but the class name is Mac. Here, the class name is Mac. So you need to prepend the Mac for you to access the third variable, right? So okay, wait, but baliktad. Anyways, here. So this is actually how the TLDR of that variable assignment. So first, we are doing just a internal use weekly private assignment. So this is actually other stuff. So next, this one, the reserved keywords. So again, for those people, this kind of also mostly on data science, since data science usually do have keywords that like Python keywords that also being used on data science packages. So if you do want to use reserved keywords, this is also a convention as well. So just append a underscore after the class after the variable so that it will not clash with reserved keywords. So usually the reserved keywords is class, print, and other stuff, def. So you cannot use that as a regular variable Python. So as a summary, so this is the use cases of underscore when it comes to variable and value access. So again, technically, both of the private variables is just more on giving it conventions as well. So again, okay, that's all for the value access. So we've tackled some day-to-day Shell interactive use cases. Then we've tackled value access. So now we will go with magic methods, Dunder methods, which is I think some of you already know other stuff. But one good thing to how to actually check Dunder methods is, let us say, print that dir. Oops. Wait. Yeah. So some of the Dunder methods, actually, if you are not familiar, all Python stuff is on object. So all Python functions and anything have their own Dunder methods. So further later on the advanced part, you'll actually see what do I mean that everything have a Dunder method on its function definition. So again, so let us. I said earlier on all have Dunder methods, and everything that you use is actually defined by Dunder methods. As I shared earlier on, even the add, subtract, even representing it to string, it's also Dunder method. So some of the Dunder methods I already said earlier on, you can use dir, xyz, or technically also the Dunder method of dir. So here, this is just some of the example. This is less than or equal, less than, module, format. The DICT, dictionary is actually one of the important Dunder method for every function. So later on, we will be discussing that together with slots. Since knowing this actually is something that you kind of relevant in the AI age, because now we all know that AI can do anything. So why we bother understanding these Dunder methods or the internal conventions of Python? Because that will separate you as well with other developers that just doing vibe coding and that doing deep dive with these kind of things. Because some of these actually improve performance, and you'll learn how later on. But again, the dictionaries, that's all, is actually some of those stuff. So again, so let us go with the idea of the very, very known Dunder method. The Dunder method, Dunder name and Dunder mean. I forgot to say, Dunder means double underscore. So if you hear Dunder, it just means double underscore. So let us discuss about the double underscore name and double underscore main. So for the double underscore name, it is just referring on the idea of what's, if I remember it right, since I write this on last year. So if the double underscore name is actually referring to your Python file, what is actually you are running. So are you running it on are you running it as a script or as a on the Python interactive shell? So if you actually see it here, so I created the Python interactive shell, then import foo. Wait. So okay. So what does it show is that if you run it as a script versus importing it as a module. So for this one, if you run it as a script, it will not run the underscore, dunder name and dunder main because it is not being run as a Python module. Compared to if you run it with Python 3-m, it will actually run the code inside the underscore double dunder name and dunder main. That's the reason why we are using this with Python apps because we doesn't run Python apps as a. We usually run Python apps as on the Python 3 runner. And if we are just creating modules, we don't need to actually do this anymore. But if you're creating app, you need this because it actually checks what file and what type of runtime you're creating. So again, other stuff. There's a lot. I earlier said, earlier I showed you that there's a lot of Dunder method, but other common stuff would be init. So this is where, this is actually called every time you create an init instance of your class. So anything that you put here, instance variables, it will be directly run on the initialization part. Then let us say for string, string, dunder string and dunder representation. So this is actually the two ways for you to actually create a representation of your function as a string. So by default, this is just concatenating every characters in your function, and will be also this is also the dunder methods that's currently used by the print function. Then, as earlier on, the operator, the underscore add and any arithmetic methods, it just uses. It is also used by the arithmetic symbols. But again, as earlier I shared earlier, you can actually overload the operators as well. The length protocol, it is straightforward. The iter and next, okay. The iter and next, this is the functions that we are actually using when we are doing iterative functions, technically for loops, all of the loops, but even generators, we are actually also invoking this dunder method. So if you are actually, if you want to create custom methods or custom logic, you can use this both function. Then if you want to make your function or you want to make your class as a callable as well, you can also define your dunder method call. And other than that, the context manager, this is if you want to create a, let us say, a connection to database. So usually we have with function name to actually create to open a context manager. But let us say that's for some of the established functions and classes, right? But if you want to also create your own context manager for your own library, you can actually you can actually define the enter and exit Thunder methods. So there's a lot more, but I will not, again, earlier on, you can just check. If you're kind of curious, always, you can just always check the dir, the other method of function that you're currently doing or dealing, right? So again, okay. So, but there's are some of the Dunder methods that's actually special that helps you to increase the speed and performance of your project. So there's actually what we call the Dunder method deek. So every class and variable have Dunder method deek. So by default, when you actually assign any value on your variable, it will be stored on dictionary. So it will actually store every hash map of those things. So it is actually storing on the memory. But the thing here is that it is actually much slower since we are technically going to the memory. So for us to make it much faster, if you know what stuff you are currently defining right away and you will not be adding later on, you can use slots. So for this one, we are using, for dic, this is like the dictionary, using dictionary. For slots, we are using tuple. So for me to show you, I actually prepared the code. Wait, where's the code? Actually prepared, oops. Code. So yeah, let us just run this because it's too long. Oops. I'll just explain. So for this one, we have two classes, right? So for this one, the first class, it's actually just using the dictionary, the native dictionary. So we are storing name, price is stored on the dictionary. For this one, we are actually just saying, we are still storing it on dictionary, but we are also restricting the class to only these three variables. So when we actually do this, it will create a regular object. But when we try to add, when we try to create another variable or create a class variable, on the regular item, it will actually throw an error. It will actually successful added because we are not restricting it with three variables only. But when we are using slots, even though we just have the same class definition, we will get an attribute error. We will not be able to add discount since we just are restricted on slot. So again, this is kind of much more, there's much more deeper explanation. So you can check the video of Anthony on how does actually slots work furthermore. Okay. So other than that, we also have missing. Let us say usually what right now on the modern Python we don't access. I mean we still access dictionary things. Let us create like simple dictionary. Um, yeah. So here we usually access it like this. Right? So we are using it, we are accessing it like using its index name, right? But on modern Python, we can actually use the keyword get to safely access anything on the dictionary. So if we do B, it will not throw an error, but if we do B here, it will throw an error. So you can actually replicate this with the Dunder method missing. So if you're creating your own class as well, for you to have safe access as well, you can define the missing Dunder method and you can create your own logic there. So it is more on the side of debugging as well. So again, earlier on I said you can actually make your class as a callable object like function using call. All. So for this one, this kind of behave like the slots. So usually I think if we do, eh, um, if we okay here, I'll just show you. If we usually if we do different apps, right? We usually just import anything on the init py, and when we import the tools as a function, we will be able to call every imported files. But again, the thing here is that if you use all, similar with slot, it's actually restricting anything that is only defined here will be the only stuff that you can actually call or import on the other modules. So it is, we are just more on stricting and make it much faster versus like always checking different internal use cases. So again, that's how we actually do it. So for here, even though we defined secret function, if we define all, we will not be able to call the secret function because it is not on the definition of that function when we import it. So again, I'll just pass explain this. This is also explained by Anthony, and I think Anthony explained it much better than me. But I just want to share sometimes why function in Python actually takes much slower than regular stuff. So things are, we just have two concept, data versus non-data descriptor. So as I said earlier on, every function or technical variable have its own getter and setter. And we can also define our own getter and setter on our class using property, setter, and yeah. So we can actually define that, right? So ideally, there's actually just, the thing you just need to know is that if your function is actually using data descriptor, it is technically, even you define dictionary and everything, it will just check first the get function. So it will always do the get function and get function. So it is strict. You cannot set or anything. It will just first go through with get function. But if it's not a non-data descriptor, you can bypass those checks and directly go to the internal attributes, right? So that's two things that you need to remember. If it's actually it's a data descriptor, it is doing a round trip first before you will be able to access the attribute. And if it's not a non-data descriptor, you can actually directly access attribute. So for this one, okay. So for this one, we've defined non-data descriptor, right? So here we define the get. So if we, okay. Yeah. So here, if we actually define the attribute, we will be able, here, we are invoking the get function. But we can also, since this is just a non-data descriptor, we can also set information on the attribute itself, on the variable itself, and we will be able to just get it right away. But on data descriptor, if you did that, you will be having error. You will be actually not having error, but if you see, there's a get here, right? Getting from descriptor, setting to this descriptor. So instead of just doing one trip, it will do a round trip. So it will first setting, getting, and assign. So it will do, instead of just assigning right away, it will do the two setter and getter environment. So yeah, so technically, this is the final attribute access logic. So when you have, when you're accessing a certain attribute, it will look first for the dictionary class. If it found and it has getter, it is a data descriptor. So it will use first the set, then get, then access. But if it's not a data descriptor, it will directly push through on the dictionary. That's the reason why we need to actually know these kind of things, because at the end of the day, you can always override these methods so that you'll be able to access quickly these kind of things. Again, that's a lot, and I hope I have a lot of time. I'll also attach the video from PyCon Davao here so that you'll be able to refresh what I talk about here. Again, thank you, and yeah, that's all for me.